Hello students, so continuing our lectures on Matlab. Let us first try to understand what do we mean by when we write C is equal to 5.66 inside a third bracket. It indicates that this is a scalar or a 1 into 1 matrix. Now, similarly, if we write X is equal to 3.5, say 33.22, 24.5. Then X is a row vector or 1 into 3 matrix. Similarly, if we represent Y as equal to 2, we write in this fashion 5 and 3, then Y is a column vector and it's a 1 into 3 matrix. Now, if we write it in this fashion, 1, 2, 4, enter 2 minus 2, 2, 0, 3, 5, 5, 4, 9, and close the third bracket. Then A is a 4 into 3 matrix. Now, if a matrix can be defined by a number of Matlab expressions, if we're talking about row vector X of the order 1 into 3, and we can represent the row vector as equal to, say, 2, comma 4, comma minus 1. This is one way of representation. Another way of representation is if we just, instead of putting comma, we put a gap in between the numbers 2, 4 and minus 1. Either of the ways is a correct way of representation. Now, to call the elements of the row vector X, we put the command x1, then it will be equal to 2. We put the command x2, it will be equal to 4. And if we put the command x3, then it will be equal to minus 1. So this is how we can represent. Similarly, we can also represent a 2 into 4 matrix in this fashion. Suppose there is a matrix which is Y is equal to, say, it's 0, 2, 2, 3, and 5, minus 3, 6, 4. So here the 1, 1 element is equal to 0, the 1, 2 element is equal to 2, 1 3 is again 2, and 1 4 is 3. Similarly, y 2 1 is 5, y 2 2 is -3, y 2 3 is 6, and y 3 sorry y 2 4 is 4. Now instead of representing the matrix in this way, there is another way of representation, that you write y as equal to 0 2 2 3 semicolon 5 -3 6 and 4. So the semicolon here is very important. It is used to differentiate the matrix rows. Used to differentiate matrix rows when they appear to be on a single line. They to be on the single line. Again, as we have already seen, the individual element of a matrix can be represented as ij. Now, the elements of the matrix can also be defined with algebraic expressions placed at appropriate locations of the element. So, the elements can also be defined as algebraic expressions placed at the appropriate location. For example, the matrix can be presented as A sine pi by 2. So in the Matlab command, instead of writing the using this pi, we write it as pi. So pi by 2 is qrt square root 2 3 plus 6 by 3 sorry plus 4 6 by 3 exponential 2. This is also a way of representing the matrix. So if we give the command in the Matlab window, we put it, the answer will be like this. A is equal to 1.0000, then 1.4142, then 7.0000, then 2.0000, then 7.3891. So the first, as you can see, the first one was sine pi by 2, so that gave it a value equal to 1. So you can see here, the first expression is 1. The second one, the second value was square root of 2, which is, again you can see, is 1.414. So this is the square root of 2. The third expression was 3 plus 4, so that makes it 7. So you can see here, it's 7, so this is 3 plus 4. Then again you have 6 by 3, which is equal to 2, so we have expression 2. And lastly, the last expression was exponential 2, which is, again you can see, is 7.391. So this is how you can represent the matrix. Now, the matrix can also be defined by augmenting previously defined matrices. So, matrix defined by augmenting previously defined matrices. For example, the matrix X we have defined earlier as equal to equal to 3.5, 33.22, and 24.5. So sorry, this is not the matrix. Matrix X, let's say, is 2, 4, minus 1. So we write the matrix as another matrix x1 as equal to x 5, 8. So what it will do, it will simply add these extra 2 elements at the end of it. So then x1 is x1 then is the matrix 2, 4, minus 1, 5, 8. This is another way of presentation. Now in this case, if we simply write x5 is equal to 8, then it will create the matrix x is equal to 2, 4, minus 1. So since there is no fourth element, so it will take it as 0, and the fifth element it will add as 8. So 2, 4, minus 1, 0, 8. Now this value is this is basically the x is equal to 4 value, which since we don't have any input, so it is taken as 0. Now let's see if we have a matrix again, say C is equal to 4, 5, 4, 5, 6, 3, and we previously defined the matrix Y as this one. This was the matrix 0, 2, 2, 3, 5, minus 3, 6, 4. So write it again. Y is 0, 2, 2, 3, semicolon, 5, minus 3, 6, 4. And if we say another matrix Z is equal to Y semicolon C, so it will add an extra row. Since we have seen that the semicolon is used to indicate an extra row in the matrix. If we are writing the whole matrix in a single line, so it will indicate that Z is actually equal to, first we'll write the Y matrix, it was 0, 2, 2, 3, then 5, minus 3, 6, 4, and the extra row added would be 4, 5, 6, 3. So this will be the output.